How can we use area models to find the factor pairs of a number? For example, find all the factor pairs for the number 20. In this lesson, you will learn how to find all the factor pairs of a number by using area models. Let's review. We know that multiplication can be shown as an area model. The array here shows 2 rows of 3. We also know that 2 times 3 is the same as 3 times 2. This is the commutative property. We list these factor pairs one time because we know that 2 times 3 is the same as 3 times 2. Let's review. 1 times 6, this one right here, the 1 and the 6 are the factors. We can also show it as an equation. 1 times 6 equals 6. The 6 is the product. A common mistake many people make is to forget to list the number as a factor of itself. When finding the factor pairs of 6, list 6 as a factor of itself because 1 times 6 equals 6. So, how can we use rectangular arrays to find all the factor pairs for 6? We can create our first array, and we know that's 1 times 6. Then I go to the next number from 1 to 2. I know 2 times 3 equals 6. Now I see there's a 1, 2, 3, and all we have is 4 and 5 left, and there is no way to arrange rows of 4 or 5. Thus I have all of my factor pairs. I can write them out now, and I write 6, then the colon, which says there's a list, and the factors are 1, 2, 3, and 6. Let's go back to that question we had in the beginning of the lesson and apply what we have learned. Find all the factor pairs for 20. Using my area model, I have 1 block high times 20 blocks. I now move to the number 2. I know I can make 2 rows, and that's 2 rows of 10. That equals 20. There is no way to have 3 rows because 3 times 7 is 21, so that doesn't work. So I go into 4. I know 4 rows of 5, or 4 times 5 is 20. Now, my factors are close to each other, the 4 and the 5, and that's one way I know that I have found all the factor pairs. I can mentally run through the list. 5, let's see, 6, that won't work. 6 times 3 is 18. 7, we already tried that. 8 doesn't work. 9. So we are finished. I then write 20, put the colon, the 2 dots, and I list my factor pairs from the smallest to the largest number. From least to greatest, they are 1, 2, 4, 5, 10, and 20. Now we can see why using an area model can help us find all the factor pairs for a number.